Think Orbital, based in Boulder, Colorado, USA, is a space startup dedicated to constructing enormous, scalable structures in space. With a single launch, they can build large pressurized and unpressurized space platforms. Later in this video, we'll look at the technology that makes their plans possible. The company expects their space platforms to serve multiple purposes, such as satellite servicing, space debris removal, in-space manufacturing, research missions, on-orbit storage and refueling, and space tourism. Think Orbital focuses on in-space assembly, particularly space welding, which enables the creation of vast habitats or structures in space. This expands humanity's foothold in space through safe and scalable space infrastructure. Their mission is to not only construct, but also protect the critical infrastructure necessary for a flourishing space economy. The company's aim is to turn science fiction into reality by building platforms that cater to all of humanity's needs in space. You might have guessed by now, based on the number of times defense and military applications have been mentioned, that the team has a background in the US military. You'd be right. Their co-founder, CEO, and president is Colonel Lee Rosen, retired US Air Force. He was a former SpaceX vice president and involved in over 200 successful missions with SpaceX. He led the building of 3 Falcon launch pads, Dragon spacecraft operations, and astronaut training. The company has received some pre-seed funding from venture capital funds. Their current funding level is believed to be around $3.5 million so far. Technology. A key piece of technology Think Orbital is developing is their robotic arm. The company calls it the Think Toolkit, that includes a robotic arm and end effector designed for space servicing, construction, inspection, and military operations, including counter-space activities. The breakthrough needed to build large structures in space is the ability to position and fix, through welding, structures in place one by one. The size of the finished structure is limited only by the size and capability of the robotic arm welding machine. From the graphic, we can see it consists of 3 features. First, there's the systems module equipped with cameras that can see in the X-ray spectrum. This is crucial for detailed inspection. Next, the robotic arm itself boasts 6 degrees of freedom and extends to a length of 2 meters, providing the necessary flexibility and reach for complex tasks. Finally, the end effector serves multiple roles. It's used for welding, cutting, additive manufacturing, and inspection across X-ray, visible, or infrared spectra. Together, these components enable in-space servicing by allowing for welding, cutting, and additive manufacturing. The robotic arm can be used for anomaly diagnosis, along with servicing in addition to assembly, manufacturing, and construction. Let's look at the key piece of technology that's relevant for space construction. Electron beam welding. Electron beam welding is arguably the best welding technique to use in space, due to its producing welds with unmatched strength and the smallest heat-affected zones. Capable of joining up to 30 centimeters of steel in a single pass, it boasts an impressive 90% energy efficiency, critical when power is scarce in space. This method requires a high vacuum, which is both challenging and expensive to maintain on Earth. However, in space, the natural vacuum environment eliminates the need for heavy, power-hungry vacuum equipment, simplifying the process. The technique delivers extremely precise welds with deep penetration, essentially in space where imprecise welds could mean costly resupply missions from Earth. Materials suitable for electron beam welding include titanium, stainless steel, nickel, aluminium, copper, and their alloys. Now that we understand the technology Think Orbital employs, let's explore how they're using it to construct large-scale structures in space. Large-scale space structures. In-orbit robotic assembly combined with electron beam welding allows for the creation of much larger structures in space than currently possible. This technology isn't just for space, it could revolutionize habitats on the Moon as well. Think Orbital has designs for constructing orbital shipyards, domes, and propellant tanks, among other structures. Once you have this technology, the only limit is your imagination. But let's bring our focus back to the more immediate future. Many illustrations show a spherical module, so let's examine its specs and construction method more closely. Think Platform 1. This module, named Platform 1, is a spherical module designed to be added to an existing station. New commercial space station designs are being developed, and rather than build their own facility and have the complexity and expenses of running a space station, they prefer to offer their module to an existing commercial entity. This approach is similar to Gravitics, another space startup offering space modules as add-ons. According to the spec sheet, these modules come in diameters from 4.5 meters to an impressive 20 meters. At 20 meters, the module's interior volume would exceed 4,000 cubic meters, dwarfing the International Space Station's approximate 1,000 cubic meters. Some renders provided by the company show using a spherical module for sports events. You could easily imagine using one of these modules for hydroponics for growing plants in space manufacturing, or pharmaceutical production. There's a wide array of potential uses for such spacious facility. Here's a video from Think Orbital, unfortunately in low resolution, but it gives you an idea of an interior layout. Think Platform 2. Think Platform 2 serves as a central hub for on-orbit servicing, assembly and manufacturing. It provides a secure environment for the maintenance of spacecraft, satellites or scientific instruments, and can also support refueling and in-space manufacturing. Unlike the spherical modules previously discussed, this platform is a free-flying, non-pressurized facility. Crew members must don EVA suits to access it, but this design offers a distinct advantage over traditional spacewalks. It's an enclosed area where astronauts are shielded from the risk of drifting away, and tools are less likely to become space debris, a common issue during spacewalks at the ISS. Think Platform 3. Think Platform 3 is a unique blend of being free-flying and pressurized, functioning as a space station with a massive internal volume of 4,000 cubic meters, capable of accommodating up to 40 crew members simultaneously. Think Orbital considers this module will be used predominantly for private tourism and research activities. Think Platform 4. Think Orbital's futuristic vision includes the Think Platform 4, which is a complex of spherical modules interconnected by cylindrical tubes. These tubes link to a central hub with further connections to a docking port adapter and an external power source featuring mounted solar arrays. This setup could support hundreds of crew members simultaneously. The graphic bears a resemblance to the Axiom station, augmented with additional spherical modules. Interestingly, the graphic's file name hints that the Axiom station was used as a base for this design. Of course, such spherical modules could be integrated into other emerging commercial space stations. Let's go over some key milestones for the company so far. In September 2022, Think Orbital was awarded a SpaceWorks Orbital Prime contract. Think Orbital secured a $250,000 award from SpaceWorks Orbital to explore how their in-space servicing platform could enable assembly and manufacturing for the Department of the Air Force and the US Space Force. The platform in question, named Opus OSA, is an adaptation of Think Orbital's core design. Through partnerships with Redwire Space and Arizona State University, Opus OSA leverages Redwire's mature space technologies and the academic insights from Arizona State University. Jim McConnell, Chief Technology Officer at Think Orbital, said, "Our Opus OSA proposal is based on Think Orbital's core Think platform design, which relies on mature space technologies such as autonomous robotic arm assembly and electron beam welding to deliver a large volume orbital space platform. We're exploring the possibility of delivering a platform with 4,000 cubic meters of internal volume in a single launch configuration. That is 4 times the volume of the International Space Station in a single launch, thanks to developments in super heavy launch and autonomous on-orbit assembly capabilities." Unquote. Sebastian Asprella, co-founder and CEO of Think Orbital, said, "Our platform can be a great fit for SpaceWorks, as you need an orbital spaceport with large volume, be able to store and process space debris, satellite servicing, manufacturing and other outcomes." Unquote. In May 2024, Think Orbital launched its first autonomous in-space welding system. Think Orbital achieved a milestone by launching their first electron beam welder experiment aboard a SpaceX Falcon 9. The mission was a resounding success, achieving most of the objectives set for Flight 1, marking a big advancement for Think Orbital in the realm of in-space welding. They accomplished the world's first autonomous in-space well, with the samples being returned to Earth for analysis, not only by Think Orbital, but also by NASA and the European Space Agency. In January 2025, NIAC selects Think Orbital. Think Orbital has been selected by NIAC, which stands for NASA Innovative Advanced Concepts, to advance their concept of space dry dock. Other than these renders for the proposal, we don't have any more information. Hopefully we will get more information from Think Orbital in the future. Also in January 2025, Think Orbital awarded with AFWERX Phase 1 award. Think Orbital has been granted a $109,980 award by AFWERX, the innovation arm of the United States Air Force, to develop concepts for space warehousing of assets. The US military wants the option of forward deployment of assets in space. Pre-positioning assets in strategic locations has proven critical to every other military service in the US, so it stands to reason the US Space Force would want the same option. Think Orbital, with its spherical modules, has the potential to provide very large storage capacity, up to 4,000 cubic meters of space per module in a pressurized or unpressurized environment. Colonel retired Lee Rosen, co-founder/CEO of Think Orbital, said, "This commitment by AFWERX to Think Orbital's concept for forward deploying assets in space demonstrates the need for innovative approaches in projecting combat power at time and place of our choosing." Upcoming events. Currently, there are no specific upcoming events listed for Think Orbital. However, they are actively working on several projects and have secured various awards, so we can expect more information as they announce results. We're not aware of any scheduled flights for Think Orbital, though, given they've already flown once on a SpaceX Falcon 9, it seems plausible they might aim for another launch to test newer iterations of their robotic arm and ion beam welder. We'll keep you updated on their progress as soon as we learn more. Okay, that's a wrap for this video. Thanks for watching. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.